Good evening, everybody. Myself, Acharya Vishvendra, and today I'm going to discuss a worksheet on polytropic process. So the question here is: a gas undergoes a process given by PV raised to power n is equals to constant, and it goes like this. There are 2 points on the curve. Point number 1 having coordinates P1, V1, and point number 2 having coordinates P2, V2. So the first question here is n is. So as we can see from the graph, it is decreasing with V. So here n has to be positive, because if n is negative, P will be like proportional to V square, proportional to V. So with increase in volume, pressure will increase. But since it is decreasing, so n must be positive over here. Next question is ratio of P1 and P2. So we can say that P1 V1 raised to power n is P2 V2 raised to power n. So that will give us P1 by P2 is V2 by V1 raised to power n. Then is finding the volume time relation. So using the equation PV raised to power n is constant, we eliminate P over here. So we substitute P as nRT by V raised to power n is constant. So that will give us T V raised to power n minus 1 is constant. Then we need to find the pressure temperature relation. So use now eliminate V. So we have P. Instead of V, we substitute nRT by P raised to power n. So that will give us P raised to power 1 minus n into T raised to power n constant. Taking n common from both the sides, we have Pt raised to power n upon 1 minus 1 is constant. Taking 1 minus nth root of the entire equation, it will give us the relation that Pt raised to power n by 1 minus n is constant. The next is Pt graph. So since we have assumed that n is positive over here, so there are two possibilities. One is if n is less than 0. So we can say that if n is negative, then the curve will be like this. It will increase with temperature for n less than 0 or greater than 1 domain. And if n lies between 0 to 1, so it will decrease with this, as this thing will be positive. As we can analyze that from here is 0, here it is 1. So if we think for greater than 1 domain, so 1 minus n will be negative, n will be positive. So this entire thing will be negative. So that will make a proportionality like P will increase with time, as shown over here. And if n lies between 0 to 1, so this n is positive, but this term will be negative. So at all we have you can know n will be positive over here, and 1 minus n will also positive. So the relation will be like P T raised to power some positive is constant. So mathematically we can analyze with that, with increase in T, pressure will decrease. So as I have discussed above, so this is the analysis. Then is the Vt graph. Same is for the Vt graph. If n is greater than 1, graph will be like this, and if n is less than 1, the graph will be like this. Regarding volume and temperature, because here the proportionality is like this. So these are the possible graphs. Next question is work done by the gas during 1 to 2. So work done, we know that it's integration of PdV, and using the result we can say that P2 V2 minus P1 V1 by 1 minus n. Next question is change in internal energy of the gas during 1 to 2. So internal energy change is given by NCV delta T. So that will be NFR by 2 into delta T. F is the degree of freedom over here. So we take F by 2 common. And NR delta T can be written as P2 V2 minus P1 V1. So that will be the change in internal energy during the process 1 to 2. Then is next question, heat supplied by the gas during 1 to 2. So using delta Q is delta U plus delta W. We have this expression. Then is molar specific heat capacity of the gas during 1 to 2. So using the concept that molar specific heat capacity is delta Q is NC delta T. So C will be delta Q by N delta T. So that will be the molar specific heat capacity over here. You just substitute value of delta Q, and from there a relation can be found in terms of P1, V1 and N. Next question is a polytropic process is given by Vt raised to power 4 is constant. So the first thing is we need to find the PV relation. So what we do is we eliminate temperature from over here. So temperature will be like PV upon NR. So we have V P raised to power 4 into V raised to power 4 is constant. So that will give us P4 V5 as constant, or PV raised to power 5 by 4 as constant. Next is PV graph. So since this coefficient is positive over here, so with increase in volume, pressure will decrease, as we can analyze mathematically. So the graph will be like this. Then we have UT graph. VT graph. So the equation is like PV raised to power 5 by 4 is constant. So we substitute P as proportional to T by V. So the relation is TV raised to power 1 by 4 as constant. So graph will be like this. With increase in volume, obviously temperature will decrease. So it will be having a shape like rectangular hyperbola. And then we have a PT relation. So the equation is PV raised to power 5 by 4 is constant. And after calculations, we have p raised to power minus 1 T5 constant, or it is proportional to them. So we can say that with increase in temperature, pressure will also increase. So it will be like this. So the graph will be like this. The next question, we have dimension of pressure. So it is m1 L minus 1 T minus 2. Then is largest unit of pressure, it is atmosphere. Then it's 1 atm. So 1 atm is equals to 1.013 into 10 is to power 5 pascal. 1 bar is 10 is to power 5 pascal. 1 atm is 1.013 pascal. No, it's like 1 atm is 1.013 into 10 is to power 5. There is a bit mistake over here. Yeah. Then is 1 atm minus 7 is equals to 760 torr, and it is also equal to 760 of He. So you have seen that we have covered a number of questions in a video of 20 let's say 6 minutes. So it's just an optimization tool for you, so that you can cross check your preparation. In case of any doubt, you can ask in the comment section. Thank you and have a nice day.